Okay, so our next speaker. If I think about performance, there are two names that pop to mind, and one of them is Tim Kadlec. And his work is really, really fantastic. What he did helped me a lot in my workshops with design teams and development teams that want to work together. Tim came up with these fantastic tools like performance budgets that helped us very much to be able to talk to each other, to understand each other, and to understand how the web works in a much better way. Absolutely fantastic things that he did. You've probably all read all of his work, but it's really, really good. You should take a week or two to read every word of it. So I'm really looking forward to this next level stuff. So what's he going to talk about once more, but now with feeling? Ladies and gentlemen, a warm applause to Tim Kadlec.
Thank you. That was a very kind introduction. Appreciate that. You don't have to read everything. Some of it's not very good. So the brain is a really remarkable thing, isn't it? All right, I think about what's happening right now, or what's been happening really all day. You've been sitting here, you've been, taking beautiful sketch notes. You've been taking notes, you've been listening to the presenter, you've been trying to focus on what they're trying to say and processing it. Now, this is seemingly not a very complicated thing to do, right? Certainly nothing we consider to be too strenuous or exhausting. And yet, while you've been sitting there, seemingly passively consuming this, your brain has been working like crazy. You see, what's happening is your brain is receiving all sorts of sensory information. It's receiving information about what you're touching and hearing and smelling and seeing and feeling and what the temperature is. And it's taking all of this sensory input and it's processing it to create a picture of reality as you're experiencing it right now. And this is an incredibly complex task. So for example, each of these different forms of input are processed at slightly different speeds. Your brain processes touch much more quickly than it processes sight or sound. And yet, if I were to do this, it doesn't feel like 3 or 4 different things, right? My brain manages to combine the touch, the sound, the sight, all together to create one unified event, one clap. So to do this, it has to process this input, it has to line it up in an orderly fashion, it has to filter out what doesn't matter. I mean, think about all the things that you're hearing or seeing right now that aren't related to whatever it is that you're focusing on. Your brain is finding a way to, push that off to the side. And then it has to apply some sort of pattern recognition to it to infer some sort of meaning about these signals. And this pattern recognition is based on our past experiences and based on our past beliefs, which is why some of us will look at a piece of toast and see a rock star, and other people see something that's going to be delicious with a little bit of jam on top. But this pattern recognition is also very powerful. It's what enables us to do something like this. We can take a series of lines and dots and shapes, and if we arrange it just so, we see a face, even though this is just a bunch of shapes just randomly constructed. And this is what people mean when they say that perception is reality. Now, this isn't entirely true, right? There are certain things that are real no matter what. The edge of the stage is very real, and if I were to fall off of this, no matter what I perceive is going to happen, it's not going to be very comfortable for me, right? So a more accurate statement would be to say that perception frames reality. It's the lens through which we view it. And it's all very impressive, it's all very complex. It's also fairly fragile and prone to manipulation. So how many people know who this is? Does anybody? This is, right, Adele, right? Everybody's favorite, pop singer, wonderful human being. And everything looks sort of normal, except it's, upside down. So we'll fix that right now. Suddenly, her song, Hello, seems a lot more ominous, doesn't it? Right? I'm sorry about this, by the way. I don't know if the conference is going to be able to, fund any of the therapy that you'll need after this to deal with the nightmares. But so what's happening here? This is the exact same photo, but when we look at it upside down, it looks fine. She looks like a normal human being. What happens is our brain is looking at this, and we see a face pattern here, and we see key points of this face. The eyes and the mouth in particular are very key. Now, those eyes and the mouth happen to be the only things that are inverted, by the way, the right side up. So our brain sees this, it knows what a face should look like, it assembles it all into this face pattern, and it says, oh, it's fine, it's a face. And it's only when it sees it dead on that it realizes just how messed up things have become. Let that linger a little bit. No, I want to give you another example. Look at these two shapes, all right? Now, one of these is a kiki, and one of these is a booba. They're both very fun words to say, by the way. You can do this when you get home. I've practiced this single slide more than any other slide ever because I get to say kiki and booba repeatedly. Now, who thinks that shape A is the kiki? Okay. Who thinks shape B is the kiki? Yeah, I see like a couple hands, not very many, right? All right, well, I guess everybody's wrong, actually. These are both just abstract shapes that have no meaningful name attached to them, right? But when studies like this are repeated over and over and over again with two abstract shapes, and one of them has sharp angles and one of them has this sort of a blobby feel to it, over 90% of people will say that shape A is the kiki. See, what happens is your brain is desperately trying to make some connection, desperately trying to figure things out. And all it has to go on is the shapes that you see and the angles involved, as well as the sound and the shape that your mouth makes. So if you say kiki, k is a very sharp sound. And if you say booba, that's much more full, and in fact, your mouth sort of rounds out a little bit. So your brain says, okay, there's a k, very sharp angles, that must be the kiki, and booba must be the blobby thing. It creates meaning where there is none. So our brains are powerful, but they're also easy to mess with. And one of the easiest ways to screw your brain up is to manipulate time. Now, how many people think that 300 milliseconds is a very long time? Can I get a show of hands on that? Okay, there's like, nobody. Okay, every once in a while there's like one person who puts up their hand, and I'm like, that person is doing performance work inside of their organization. Like, that's the performance optimist in the crowd. No, it's not. I wanted to show you. I want to show you what 300 milliseconds is, and I thought, how could I do this in the most dynamic and exciting way possible? And this is what I came up with. We are going to move this square from one end of the screen to the other in 300 milliseconds. I know it's pretty riveting. All right, is everybody ready? Here we go. Let me see that. Let's do it one more time. They're pretty exciting, right? Now, I don't know for sure, but I'm willing to bet that there's nobody in the audience right now who's sitting there thinking, Tim, that is 300 milliseconds of my life I am never getting back, right? Nobody's thinking that because it's not a long time. It's not much. And yet, there's this wonderful video of people walking around using an Oculus Rift, and they saw reality, but with a 300 millisecond delay. That was it. That's what was being fed back to them, just a little bit of lag. And it turned them from functional human beings into complete oafs. It does not take much time to mess us up. And when it comes to digital interfaces, we're susceptible to delays even smaller than that. Numerous studies have shown the impact of 100 milliseconds, most noticeably those done by Walmart and Amazon, where they found that for 100 milliseconds, shaving 100 milliseconds off your load time resulted in a 1% increase in revenue. Now, again, nobody sits there and thinks, oh, geez, it's 100 milliseconds slower. I'm not buying this yodeling pickle. That's not what happens. What happens is it's just enough friction to throw us off, just enough to mess with what we would have done otherwise with that site, that we start to alter our behavior in some sort of meaningful and measurable way. In fact, 100 milliseconds ends up being a very important threshold when we talk about perception of performance. Studies as early as the late 1960s showed that 100 milliseconds is how long we have to respond to user interaction if we want that to feel instantaneous. There's a direct connection if we can respond that quickly. Those same studies found that we have 1,000 milliseconds to keep the user from getting distracted. If we respond anything over this, they start to focus on other tasks, their mind starts to wander. If we want to keep them in a state of flow, we have 1,000 milliseconds. So these are massively important performance thresholds from a perception perspective. But they present, let's say, a little bit of a challenge, because I like to be optimistic, a little bit of a challenge on the web, because there's a lot of work that goes into getting something to display on your screen. So let's walk through it. Let's say that I want to load the front-end site on my phone. Here's what happens. I enter in front-end conf, and I press or tap enter. And what happens is the first thing is the browser needs to figure out, okay, I've got this front-end conf. Where is this? Where does this live? So it performs a DNS lookup. It turns that URL into an IP address for some server somewhere. Now, hopefully, ideally, this doesn't take any time at all. So if this is a site you've visited a lot, your browser tries to cache it, your operating system tries to cache it, but in reality, it can go actually quite a ways out and actually have to go out and do a significant lookup. If you're curious, you can look. Chrome has all these secret things that they don't ever really tell you about. There's a Chrome : // histograms that has a DNS section inside of there. We can see how long does it take to do this DNS lookup. And now when I did this on my Canary, because I didn't want to incriminate myself with anything on Chrome, inside of Canary, what I found was that 80% of my DNS resolutions were taking between 20 to 100 milliseconds. So as much as I'd like to think that they'd all be cached, that's not the case. So now we've got this IP address, so now the browser has to establish a connection to that server. So it does this through a three-way handshake. It sends a packet of information to the server responds, and then you respond back to the server again. I have a colleague who calls this the yo, what's up, sup handshake. He doesn't get out a lot. So you open up this TCP connection, and now increasingly we have another step involved, which is the SSL negotiation, because HTTPS security is massively important. Also because browsers are taking away our toys if we're not using HTTPS nowadays. And so this can involve another 2 round trips to negotiate the SSL connection. And now finally, at this point, we are now ready to request the actual asset, the actual initial HTML. And if we're lucky, if they've done their homework and they've optimized this and it's less than, say, 14 kilobytes, we'll get it in a single round trip. And if it's bigger, we have to keep going back to the server until it all comes back to us. This is all what happens for the initial HTML. We haven't downloaded any images. We haven't downloaded CSS, JavaScript, anything else. Let's put some times to this. Let's say it takes 50 milliseconds to hit out to that server. We have a 100 millisecond round trip. Now, this isn't blazingly fast, but it isn't horribly slow either. If you load this up on a mobile connection, it's likely to be much, much slower than this. In fact, there's additional steps that go into queuing up the mobile network. So when I say that it can take 400 to 500 milliseconds to get that initial request completed, that's kind of a best case scenario. That's a very optimistic outlook. We've blown half of our performance perception threshold already. Now, this is why every performance advocate ever has gotten on stage at one point or another and in the middle of a performance talk said that the fastest request is no request. We all have to say it. It's part of the thing. Like if you're going to be in the club, the performance advocate club, you have to agree to say this once a year, and you have to master the secret 3-way handshake. It's very intense. And I kid a little bit, but there's a reason why we all say this, and this is because everything that you add to your page has to have value because everything absolutely has a cost. There is nothing that you add to that page for free. And so you need to balance this. And the challenge we face increasingly is that if we ask ourselves, is this worth it? Should we include this image? Increasingly, the answer is yes. People want faster experiences, but guess what? They also want richer and more immersive experiences. Their expectations are rising on both ends. So increasingly what we have to answer is how do we balance this? How do we balance this fidelity with speed? Now, this is typically where we often jump off into a long list of technical optimizations. And I'll talk about a few mechanics, as Andy called them in his keynote. And I'll talk about a few of those. But I want to stop first, because I think by rushing into that right away, this is why we've gotten ourselves in a situation where everybody has always viewed performance as like the developer's responsibility. And this is improving, by the way. I mean, you're seeing performance talked more and more at front-end design conferences. I mean, there wasn't that long ago that like it just was not. You could go to those events and just not hear a word about performance. And now it seems like every conference has a couple talks related at least. But it's still, you can't overstate the importance of breaking this mindset, because there's a serious risk in viewing performance purely from a technical lens. There's a really great story about a multi-story office complex in New York City. And this was years and years ago. And they got a lot of complaints in the building about this elevator, right? So people would get in the elevator, especially during peak times, and it would take forever to get from their office down or back up to their office. Very, very slow. And they complained about it all the time. Enough that the manager of the building felt like he needed to do something about this because it was becoming a real issue. And so what he did is the first step was he took a bunch of engineers and he hired them to do some research on this elevator, find out why is it slow, what can we do to speed it up. And so they went away, they did all sorts of measurements, all sorts of data and studied, paid them a lot of money to do this, and they came back and they said, sorry, we can't do anything. There's nothing we can do to make these elevators faster without seriously compromising safety. Now this wasn't, it could get exciting, I guess, with them rocket blasters or something. Now, this wasn't going to cut it, right? Because the complaints were still there. So the manager did what managers often do. He called a meeting. And as legend has it, in the meeting, what happened is everybody was going around the table trying to figure out, all right, what do we do about these slow elevators? How do we speed these things up? And one person was a recent psych major, and that person thought about it from a different angle. Instead of thinking about, like, why are the elevators slow? What can we do to make those faster? He said, okay, wait a minute. People wait a lot during the day. Like, there are a lot of things that we wait for. What is it about the elevator that makes them feel compelled to complain about it? What is it about the experience of being in an elevator that is so slow, that bothers them so much? And he thought, okay, well, maybe they're bored. They're in a metal box. There's nothing to do in this metal box. They're shoulder to shoulder with people that they may not know, or maybe they don't even like, and they've got to go up and down to their office. They want to get to work, or they want to get home. Like, maybe they're just really, really bored. And so his solution was to slap mirrors in there, which now is pretty much a standard, right? This highlights, by the way, when the story took place. Nowadays, like, what we do to distract people inside of an elevator is we'd make a Pokestop, or like drop a lure, or whatever it is that the kids are calling that with the Pokemon Go thing, Yeah, they didn't have that back then, so they resorted to mirrors. And the thinking was this, like, if there was a mirror there, I no longer have to be, like, just bored doing nothing, right? At least I can look at myself. In fact, I can people watch a little bit in the mirror, right? And it's apparently less creepy to do it that way than to just stand there like this. I don't know. But this was his thought process, and it worked. They put the mirror in there, and people stopped complaining. Now, the lesson here is not that we are vain creatures who love to stare at ourselves and each other. Not all of us. The lesson here is that performance, it's about the user. It was only when they shifted the focus from the technical limitations to what the experience was of the user that they started to identify how to actually address the problem. And this is so key, because once we look at performance from this perspective, it's no longer about technical limitations. Now it's about creativity and what we can do with it. So backtracking and looking at this elevator experience and why exactly this fixed things. If we're talking about any wait process, right? You have a starting point, I walk into the elevator. You have an ending point, I walk out of the elevator. And you're waiting all the way in between. This works for websites. I click a button, I wait till the page loads. At the end, boom. You've got these 3 basic stages of waiting. And there's a wonderful article on Smashing where they dove into this. And he dissected it based on passive waiting and active waiting, 2 stages of waiting. Now, passive, you have no choice. You have no control over the waiting. Like, you're just sitting there with nothing to do, nothing that's going to make things go faster, nothing to really distract yourself. You're just passively waiting for something to happen. And then you have the active state of waiting. This is the opposite, right? You've got some sort of physical activity you can do, maybe some sort of a mental activity like visual processing, something like that. Something to either help you get to your goal or at least distract you a little bit while you're waiting. Passive waiting is the killer. So studies about, like, waiting in line and queuing and things like that show that people overestimate passive waiting times by up to 36%. If you are sitting there with nothing to do, it feels like it takes a lot longer. I mean, it's not a big shocker, right? But if we're talking about improving performance from a perception perspective, this means that we need to shift as much of this passive waiting to active waiting as we can. And there's some really great examples of how to do this. One of my favorite has been, iOS has been doing this for a long time inside of Safari. When you go to open a link in a new tab, you get this nice little animation where everything sort of flips back, and then the new page comes up, and then it flips back on top. And this is far from superfluous, right? This has a lot of actual value being added. So for one, there's the mental model, right? It's communicating to you that those other pages are not being destroyed. They're behind this page in some sort of a digital stack, right? So that helps. But there's also, as soon as you tap that button to open in a new page, Safari starts to go through the process. It goes through the DNS lookup, establishing the connection, SSL negotiation. It gets about a 300 millisecond head start, and as we saw, that can be kind of a big deal. So by the time it's actually in place on top, it's already kind of gotten a head start on getting everything loaded as much as it can. Now, this used to be a pretty complicated thing to pull off on this web, this idea of sort of getting ahead of the user and what they were trying to do, but that's starting to get a little bit more easy with the addition of a few new technologies. One of these is resource hints. So resource hints is, in 2011 or so, I think it was, like WebKit wrote this article about the preloader. Has everybody heard about the browser like parses the HTML, finds the assets, and figures out when to download them? Well, WebKit was like, well, what if we sped things up a little bit? Let's let the browser sort of look ahead and try to preload some of these assets as much as possible. It was a really huge improvement for performance. It's like 20–25% improvement. Now every browser does this. Every browser tries to look ahead and figure out what to load and when, and do it ahead of time. The problem was that developers never had a way to communicate this to anybody. It's completely beholden to the browser. Resource hints lets you tell the browser what to do. The resource hints lets you tell the browser about your site or your application, what you know that you're going to need. And so the browser can take one or more of these steps and get a head start on it. So I want to walk through these very quickly. Resource hints can be included on your page in one of three ways. It can be included as a header. So on your backend service, you can be adding like a preload header or something like that. As a meta element, like you would a CSS file. Or I'm sorry, as a link element, as you would a CSS file. Or dynamically via JavaScript, which is where it gets really interesting, because now based on user interaction, you could start to preload or prefetch some sort of an asset or a domain. And this takes different forms. So DNS prefetch is the most basic. DNS prefetch, you pass it a domain name. Now this is great for if you've got a third-party asset, but you have no idea what the actual URL is going to be, but you know it's coming from, totally not messing with your security.com or whatever. You can pass it that domain name, and what the browser will do is it will try to do this DNS lookup ahead of time. Now this is probably a minor impact, maybe more substantial on a mobile network, but it's a really tough one to like implement and then go back to your bosses and see, look what we did, because there's so many variables as we talked about with DNS lookup. It might be saving you 20 milliseconds, it might be saving you nothing because it would have been cached anyway. But it is there, it does give you a little head start. A better option would be to use pre-connect. Pre-connect does the exact same thing. You pass it the domain name. The difference is that pre-connect will go through the entire process of DNS lookup, TCP connection, and SSL negotiation. So now we're talking a much bigger boost. Now the only problem with pre-connect is it's not as well supported, but progressive enhancement is fantastic. So what you can actually do is just include DNS prefetch and pre-connect in the head of your page for the same domain. And for browsers that don't support pre-connect, they'll do the DNS resolution and you'll be good to go. For browsers that do, it's going to go ahead and try to go through the entire process. And the browser is smart enough not to try and open up multiple socket connections to the same domain. It's going to collapse it down. So there's no risk at all in doing this. Now, preload is technically not a resource hint, but everybody talks about it as a resource hint, so I'm just going to get on the bandwagon and do it as well. Preload is for a specific asset. In this case, I'm saying, you know what, I know I'm going to need this CSS. Load this as soon as you can. And so what the browser is going to do is it's going to do the whole thing. It's going to, if it's a different domain or whatever it happens to be, it'll go through the whole process, make the request, and store that asset in cache so it has it. So later when it comes to that CSS file, it's already there. It doesn't need to do anything to go get it. Now pre-render is the this is the resource hint that's been taken at steroids. Pre-render is saying for the next page navigation. I'm pretty sure they're going to go to this page next, go ahead and load it, and not just load it, but basically load an invisible tab, load the HTML, the CSS, the JavaScript, apply it, execute it, do the whole thing, everything, so that when you, if they go to that page, what happens is it's an instantaneous swap. It's boom, it's right there, right? It's done everything ahead of time. This is powerful, but this is also where you have to start to be a little bit more careful, because if you were pre-rendering, like, when pre-render first came out, I worked with a company that was like, oh, pre-render is awesome. And it is, like, if you've ever seen it work, it's amazing. And they're like, we're going to pre-render everything. So they put like 40 pre-render links on the homepage, and just browsers were crashing left and right. I mean, like, they were killing everything. Now, I don't know. I'm pretty sure you couldn't crash a browser on pre-render now. I haven't tried for a while. I'm guessing that the browsers are a little smarter now. But you still have to be careful about it from a user perspective, because if you just start pre-rendering everything all willy-nilly, then what's going to happen is that you potentially waste all of the user's data before they ever have a chance to, if they may not ever go to that page, but you've just spent, 1 megabyte or whatever of their data without them needing it at all. So you do need to be careful there. There's a responsibility involved in pre-render. So it works really great if you have a funnel, like a shopping funnel or a marketing funnel that you know they're going to kind of go down. So that's, we talked a little bit about, so resource hints are huge. It's a great start. And we talked a little bit about like the network side of things. But now I want to get in on what happens in the actual rendering of the page that we can speed up. Because there's much, much more we can do. So very quickly, once we've gotten past all this initial request stuff, what happens is the browser looks for the HTML, the JavaScript, and the CSS. These are the three important things. This is what it needs to build your page. It needs the HTML to create the document object model, the CSS to create a CSS object model, a representation of all the CSS that might apply to the elements on your page. JavaScript kind of blocks everything because JavaScript can manipulate both. You could do something like document write the lyrics to some Beastie Boys song, or apply the change the height on an element, which changes the CSS object model. So this is what we mean when we say JavaScript is blocking. It has to assume that the JavaScript's going to screw something up. Once it has a document object model and a CSS object model, it pairs the two to figure out what is going to actually be rendered. Comments, HTML comments are going to be in your document object model. They don't ever get rendered. They're not going to be in the render tree. And finally, once it knows what it's going to need to render onto the screen, it does layout. Think of this as sort of Legos with like little blocks and figuring out where they're going to go, and then paints it out onto the screen. Now, when we talk about this route, this path from that initial request down to that initial paint, that's the critical path, if anybody's heard this term before. And so anything that stands in the way of that initial paint is critical. So let's talk about a very simple example here. We've got some HTML, not much going on, but we already have three critical resources. The first is the HTML itself, right? You can't do anything about that. The browser needs HTML to make a page. The second critical resource is the styles, because it needs this to create the CSS object model. And the third is our script. So let's focus on our script first, jQueryAcular. It's probably in production somewhere. So what happens is typically our browser comes across this script tag as it's parsing the HTML, and it has to pause things. It has to pause so it can parse and execute that script, because the script could manipulate something, so it has to assume it will. So it stops everything so the JavaScript can do its thing, and then continues on from there. So it's a very blocking, it is a huge bottleneck. Thankfully, it's not too hard to fix this nowadays. There's an async attribute, which has really good support. You can always use a polyfill. The filament group makes a fantastic one called Low.js. But otherwise, the async attribute is pretty good. I think it's at IE 10 plus. You can throw the async attribute and you'll be pretty happy. What async says is when the browser comes to the script tag, instead of pausing everything, it's going to actually parse the JavaScript in parallel. It'll parse at the same time it's parsing through the HTML, and it's only going to pause once the JavaScript's ready to execute. And then it's going to pause everything, execute the JavaScript, and move on. So we've deferred most of the blocking. There's also defer, which sounds super, super great. Defer would take the script tag, it parses it in parallel, and then it defers the execution until all the rest of the parsing has been done. This is like the nuclear option. Unfortunately, the earlier versions of IE that started to support defer have all sorts of really nasty bugs with defer and execution order, so this is probably just not something you want to do. So it's probably async or some sort of a polyfill to do that, but not the defer attribute. But if we slap an async attribute, now we've pulled the script out of the critical path, all right? So now we're down to two critical resources. So next up is the CSS. Now this is a little bit more involved, right? So if we go back to our site, if I load the front-end conf site on my phone, this is S7, there's only this part of the page that actually displays. Now there's a ton of content down below this, right? But it's not content I care about for the initial load, because what I'm looking at is what's on my screen at the moment, what's on inside of this initial viewport. And so if we think about it from that perspective, we can look at just the CSS that applies to only those elements within that initial view. That's my critical CSS. That's what I really need to get that initial paint. The rest of it can come in after the fact. So what you do with that is you can take and instead of loading the full style sheet, you find those critical CSS, the styles that apply to those elements in that initial view, and you inline them. And then you load the rest of it asynchronously after the fact. So now when the browser downloads the HTML and parses it, it doesn't need to make another request to the CSS. It has all the styles it needs to give you that initial view. And then you load that into place. And at this point, we've now got it down to one critical resource. If we make a request for this HTML page, we make one request, and the initial render can occur. Everything else can be kind of deferred until after the fact. Now, whenever I talk about critical path optimization or critical CSS, or anybody who's new to it, even including myself when I first started with it, it feels kind of complex and like a lot of, let me back up. One of the things is a little bit more like inlining CSS, bad taste in anybody's mouth, right? Like anybody who's like spent a lot of time like historically like with the standards and the separation of concerns, inlining CSS, it makes you feel a little bit like Jim Carrey in that Ace Ventura movie where he's like taking the plunger to his face in the bathroom. It doesn't feel very good. It feels a little icky, but you know what? We just got to get over it because it works really well. That's tough love. The second thing is, like, is it too much work? Are we getting enough bang for our buck here? Now, it's definitely too much work if you're going to try to hand do this. Critical CSS by hand, it does not work. It does not scale. You'll quit before you even do it once. Like, it's just not. You optimize it. You put it inside of a build process. You use a service that automates for it. You have to automate that process because there's just too many variables. It's too complex. But it does make a meaningful impact. Filament Group took a Wired article, and they loaded it up on a 3G connection. Now, at the top, you see the original Wired article, and on the bottom, you see the new, improved Filament Groupized article. So they didn't change anything in terms of the number of requests or the weight of the page. They didn't change any of that. All they did was what we just talked about, deferring scripts where it was necessary, including some critical CSS where it made sense, just optimizing for that critical path. And what happened is that stuff started to paint on the screen about 9 seconds earlier. 9 seconds earlier, I get to see some text, a headline and paragraphs, and everything else comes in after the fact. Right? It's a much better experience, even though the wait, the official load time, and the requests actually haven't changed at all. And you see all those white screens? That's that passive waiting that we're talking about, right? That's all that passive waiting time where there is nothing to do. Now, I know, it's one thing to do this for, a news article site, but if anybody's working on some sort of a commercial service or a credit card transaction kind of thing, sometimes there's a lot of background processes. And I know because I've worked on some of these systems where the background system is so old and so much back and forth that it just takes forever and there's nothing you can do about it, right? So what do you do when we can't get rid of the passive waiting time? I'll tell you what we do now. What we do now is we slap a progress bar on it, right? We put a little spinner in there. I hate progress bars. I really do. I do. You know what? Progress bars are the hold music of the internet. All that happens when we're using them is we're basically saying, you know what? This is going to take a little while. Why don't you just kick back? It's going to be cool. We'll throw on some Kenny G. It's going to be really relaxing. We'll have some fun. All progress bars do, all they accomplish is they focus on the waiting. They draw attention to the fact that you're waiting for something that you don't have and you have no idea when you're going to get it. This is a lesson that Luke Wroblewski learned with an app that he had developed called Polar, now defunct, unfortunately. But the idea with the app was, if anybody used this, the idea was it was a mobile application. You had a poll, and the poll was made of 2 images, A and B. And you just would tap the image that you liked, move to the next poll, tap, and keep going. It was all this sort of micro interaction thing. So you could, vote on a ton of really meaningful polls very quickly. And so since it was all based on these micro interactions, they did everything they could to make it as fast as possible. But it's a mobile application. It's going to be used over mobile networks, and they have no control over that. You could be loading this thing up on a 2G experience. And so whenever it has to go back to the server, inevitably there's going to be some delay. And so they had the progress bar, as we all tend to do. And they got all sorts of bad feedback. People were complaining about how the app was, so terribly slow and sluggish and horrible to use. And so what they did is they got a little bit creative. Instead of using the progress bar, they switched to something they called skeleton screens. And so what they would do is immediately display some gray lines, some gray boxes, a little bit of text, and sort of set the stage for all the content that was about to come in. And then as the content came back from their server, they would fill all of these little bits inside of this existing skeleton. Now, once they did this, the feedback for it being slow went away entirely. Now, what we've done, as we've just seen, is we've taken what was passive waiting for a spinner that doesn't actually do anything for you, to changing it to active waiting, where I've got scannable areas where I can start to set the stage in my mind for the content that I'm about to receive. Skeleton screens focus on the progress. It's a subtle shift, but it's a shift that frames the experience in a much more positive way. It's shifting from focusing on what you don't have to focusing on what you're about to get. And this pattern is becoming increasingly common on the web. Facebook does this. If you load Facebook on a slow connection, you get all of these gray bars and lines where the content's going to come in. And they sort of pulse a little bit. But all they are is they're empty divs with a little bit of inline CSS attached to them. So as soon as the HTML is there, these boxes can show up. So if you happen to be on a sluggish network, you'll get to see this sort of the stage set, your expectation set for the content you're going to get from all this information. Increasingly as well, the service workers, if anybody's used these yet, I know there's going to be, Phil's going to give a talk on this later that's going to touch on some service worker stuff. But one of the more popular models that service workers have been pushing for is this app shell model. The idea being that you have this sort of shell container for your application that is being cached on the device locally, and all the dynamic bits come in after the fact. I hope nobody gets any sort of seizures. I apologize for that. That's fine, just focus on me, it's fine. So what happens with this then is the application shell gets cached on the device, it loads instantly, any dynamic information gets populated after the fact. So this is becoming an increasingly common and easier thing for us to do. Now one of my favorite examples is actually, can we take a second to pop that? Just pop it and pop it back in? Great. Let's see if we got a better connection here. All right. See if there's any more exciting flickers. It's not a technical presentation or a conference without a technical issue, right? I mean, that's now it's a real conference. One of my favorite examples actually comes from, this sort of travel sites, travel comparison sites. This is a fantastic thing on Travelocity. If you go to book a flight, now they have this little loading indicator. They used to be a little bit more experimental than that. I don't know why they shifted that exactly. But what I want you to focus on is this box actually to the side. So if I submit and I say, okay, start looking for this flight for me. I need to figure this out. And what's going to happen in this box is I get this progress indicator, but in addition, I also get this feedback. It's saying checking with airlines that fly this route, searching for the shortest flights. It's telling me all of the things it's doing while it's getting all of these flights to go and lined up and queued up for me to process. Now, every time I do this, every time I give this example, there's usually somebody in the audience, arms folded across the chest. I had one person visibly go like this to me. And I was like, seriously, it was dead on, too, in the center, thinking, okay, Tim, come on, man. They're not doing these things when they say they're doing this, right? Like this, are you really falling for this? I'm not. No, I know they're not doing all of these things when they say they are, but you know what they're doing is they're telling me all the things I don't have to do. I don't have to search for the shortest flight. I don't have to sort by price. I don't have to do all this stuff because their system is doing this for me. And people love this sort of thing. They've done research specifically around the travel industry that showed this sort of an indicator versus your traditional progress bar. People were willing to wait up to 3 to 5 seconds longer for the results when they got this kind of feedback that showed them what they were not having to do. In fact, they still rated it as more valuable and faster, even though it was much, much slower. That feedback matters to people. That feedback shows progress. Feedback also helps to soothe anxiety, which is very critical when we talk about perception of time and perception of performance. Because our perception of time slows down in high stress or new situations. So what happens is if your brain is confronted with something it doesn't recognize or some sort of a high stress situation, it goes into hyperactive mode and it starts to lay down more and more memories. So when you look back at it and you reflect upon it, it feels like it took a lot longer. This is a lot of the reason why time perception changes as you get older. There's less and less new experiences. Now, how many people were here for the keynote when Andy had the nerve, the gall, to get up on stage and suggest that we might want to slow things down at times? I actually agree. It was perfect. It was a great segue because I absolutely, like, this is not anything anybody ever expects the performance guy to say, but you know what? Sometimes slower is better. Don Norman, founder of the Nielsen Norman Group, talked about a site that they had built. Now, this was an early tax site for H&R Block, application, do your taxes for you. And they built this, they designed it, they worked really hard on this, they put it in front of the users, and people were going through it, and everything seemed to be going well until it got to a couple screens where there was a lot of math, a lot of complex calculations involved. Now, we know that if we've done, does anybody like doing taxes? No, you do taxes by hand. It's painful, and there are certain steps in the process where you spend forever on it just trying to figure it out and mentally. And it would get to this part, and because it's a computer and they can move really, really fast, it would be like that. It would be done instantly. And everybody using the application was like, wait a minute, no, there's no way. There's no way you did it that fast. This takes a lot of time. Like, even though I think we get that computers are fast, like nobody trusted that the computer was doing all the work in the time it said it was. So their solution was to make it slower. They calculated everything instantly, but instead of presenting it to you right away, what they did is they introduced some artificial delays, like a random artificial delay, and be like, oh, hold on just a second, we're checking this thing and we're doing this. And then they would present the user with the information, and everybody was happy. Like, everybody's like, oh, good, now they're doing the work, it's fantastic. It's called operational transparency, exposing the work that's going behind the scenes, even when in some cases you don't need to, like it doesn't need to do all that steps. This is actually very, very common. A lot of applications using it. Facebook uses it. If you've got a security to secure your account, this process that it goes through, it does the exact same thing as Travelocity in this app. Like, it can secure your account like this. It does not take any time for it to do it. But instead, it's going to give you like 30, 40 seconds of this progress bar and checking your posts and doing all these other things, just so that it highlights all of the stuff that it's doing anyway, but it wants to make sure that you understand all of the work that's going on here. You know, Wells Fargo does this as well. Like, you go to a bank and there's retinal scanners for identifying yourself, right? They had to slow down the retina scanners because people didn't like the fact that they'd come up to verify who they were so that they could get access to all of their millions of money. And they'd walk up and it would be like, boom, okay, yeah, you're good to go. I mean, that's kind of disconcerting, right? And I love these examples. I love them because you know what? Performance, it's not a blind race to the finish line. It's choreography. That's what it is. You know, and this is one of the things that really stuck with me from Andy's talk. You know, he was talking about headings and stand-ins and how they can create a pace and a tempo to the content. You know, that's what it's about. The web isn't static, right? Your website does not stand still. Our apps, our sites, they have a tempo. They have a pace. And we have to ensure that that pace is appropriate. It requires everything. Like, it's not performance versus this. It's not. I had a friend of mine tweeted recently something about performance only mattering if you don't have content worth waiting for. That's hogwash. Here's the thing. Like, it's not anything in isolation, right? Great content that nobody can access because it's too slow, it's useless. You know, something, or optimizing the heck out of something that looks terrible, people can't process it, or there's nothing meaningful there, that's useless as well. It's every little piece of the puzzle. You know, when we're at an event like this is what I love about it so much, is that all of these talks, all of these different things, art direction, content, typography, performance, accessibility, they all combine to make that experience. They're all essential to improve the user experience. Because, I mean, put all the metrics aside. The metrics, I love the metrics. I love being able to show how much faster I made something, but it doesn't matter. It's about the user. It's about how it feels. That's what's at the heart of performance. Because how it feels matters because it's the perception that frames our reality. You know, people want these rich experiences. They want those beautiful, immersive experiences. They just don't want to have to wait for them. And if we shift our focus to the user, if we make performance truly user-centric and put them first, then they won't have to wait. Thank you.
Wow. Fantastic. That was such a good talk. Really, really good. Thank you. So what I've been working with performance when I was working a while back. Now I'm a teacher. I used to work with design teams that worked mainly in Adobe products, not so much on the web, and marketing teams that got presented these beautiful animated designs or beautiful Photoshop mock-ups. And we would have, like, say, background videos and things like that. And I was, these things are so sexy. And I asked the same question to Hayden earlier. How do we make this stuff sexy? Do we maybe need a web aesthetic or something like that? Would that help?
Yeah, well, And I think most of us have probably been there. I've done this. I had a site that I worked on that we were, it was a responsive rebuild, and we were super excited about. And we used the waterfall method, of working where the designer works kind of by themselves and then tosses the PSD over the wall to the developers. Exactly. And it was beautiful. It was this gorgeous, it was like that. It was like, it wasn't a video, it was better. It was a carousel, a full screen carousel with lots and lots of high-res and videos. Yeah, there were video. Yeah, they're right. And so that's a constant challenge because it looks beautiful on the screen, right? But once we got that into production, we got all sorts of complaints about how slow it was and sluggish, and it really kind of actually tore apart the whole project timeline too. So I think here's the thing, I think this is totally possible. It's totally possible to have these beautiful experiences and be performant at the same time, but you have to work with that in mind from the very beginning. Like the designers and the developers and the content, even the content strategists. I do a podcast with Katie Kowalson about performance, and we just talked to Steve Sodders, and he was talking about user timing, benchmarking specific user interactions on your site, and how to really do that, to really know what matters, you have to work with the content strategist up front, because that's where the priority is being decided. So it's really getting everybody in the entire team invested on it from day one, getting it onto real devices as early as possible so that you can identify those performance issues before it's too late to fix. But it is possible. You have to be creative with it. Mark Zeman had a New Zealand tourist site, which I can try to find and then link out to you in Twitter. Actually, you know what? Vitaly, there might be a Smashing Magazine article on that one, isn't there? Probably. Everything's on Smashing Magazine. Mark had this, he worked on this tourist site. He wanted to make it sort of this, like a video experience. And so when you scroll, it's these beautiful, full page backgrounds, and as you scroll, the backgrounds move, it feels like a film as you're going down, the people in the move, the activities move, it transitions, and what he did was it's all really, it loads in a second or two, it's instant. Because what he did is he took low-quality image sprites, really small, crummy images, for all of the backgrounds and load them immediately. And as you scroll down the page, starts to load in the high-resolution stuff. So by the time you get to scene 3, right now it's coming in, but your initial render is immediate. So there's ways to be experimental and creative with that.
Thanks. Any other questions? I'm sure there are questions.
Maybe I answered them all.
Oh, really? No questions. You all want ice cream. Is that it? Okay, well, thank you very much again,
Thank you.
Tim Kadlec.